We're going to be going over note card 43, which is graphing f prime of x when given f of x. Okay, there's some key points that you guys need to be familiar with before we start graphing them. And if you commit these to memory, I think it'll help out too. But really understanding why they work is probably going to be the key here. So let's start off with f of x. So if we're given all this information, it means something on the derivative. So we're going to be given this graph, and we're going to have to sketch this graph. So if you look at the f of x, whenever you have your derivative is equal to 0, in other words, whenever your slope is 0, so you can have a max, okay, you can have a min, or you can have a horizontal tangent just like that. Anytime you see any of this here, that means that there's going to be an x-intercept here, okay? It's always going to be an x-intercept. And whenever you're increasing, that means that your derivative is going to be above the x-axis. That's because your derivative is greater than 0. So over here it's going to be above the x-axis because that's when it's positive. So here it's kind of the opposite of this one. So this is going to be when it's below. So it's going to be below the x-axis. And whenever you have a point of inflection, okay, this one's a little tricky. Whenever you have a point of inflection, that means that you're either going to have something that looks like this, or you're going to have something that looks like this. Okay, so it's going concave up to concave down, or concave down to concave up. But either way, at this exact point, you're going to have a maximum or minimum on your derivative. Reason being is because if you're concave up, that means that your second derivative is positive, meaning that the slope of this one is increasing. So that means it's going up. If this is concave down, that means that the slope of this graph is negative. That means it's going down. So if it's going up to down over here, that means you have a max. Here it's concave down, that means you're going down to up. That means you have a minimum. So it's going over here. Okay, so just keep that in mind. And another trick here also, if you're ever graphing if this is ever a polynomial, the degree of the polynomial here, on this side, the degree of the polynomial is going to be n minus 1, where n is the degree of the polynomial for f of x, okay? So that means if this has 3 humps, this is going to have 2 humps. If it has 1 hump, this means it's not going to have any, okay? So let's dive into some of these examples. So the first example, we have this original function, and we have this parabola, okay? So if we go over here, it tells us that whenever we have our slope is 0, that means it's going to be an x-intercept, and we need to put a dot there, okay? So it turns out here we have a slope of 0 here. So I'm going to put a dot there, even if you guys can see it. That's going to be the x-intercept of the derivative. Now, one important thing to know here is that this function, this coordinate plane is going to graph 2. It's going to graph this original function, and it's going to graph the derivative. So we're going to do both at the same time. Okay? All right, so let's look at the other one. So if we're increasing, that means we're going to be above the x-axis. So here we're increasing on this side, so that means we're going to be above the x-axis from here to here, okay, and on. And here it says when we're decreasing, that means we're going to be below the x-axis. And we don't have any points of inflection because it's always concave up. And here's a nice little tip. So we have a second degree polynomial because it's a parabola. So anything that's a parabola here is going to be squared. So 1 less means that it's going to be to the first power, which is linear. So here I'm just going to sketch it out. So I know to the right of this I'm going to be increasing, and to the left of this I'm going to be decreasing. Which kind of makes sense because if this parabola, if the function is actually x squared, the derivative of that is 2x. So we're actually graphing a line with a slope of 2 if it were x squared. Okay? So this is the graph of the derivative, this straight line here. All right, let's take a look at this one here. So we're going to go ahead and look at where the slopes are 0. So we have a slope of 0 here. So that means I'm going to put a dot at x equals negative 3. And I have another slope of 0, which is at x equals 1. Okay? All right, now I have to figure out, okay, when am I increasing and when am I decreasing? Okay, so I'm increasing anything to the left of negative 3. Decreasing anywhere between negative 3 and 1. And I'm increasing anything after 1. And if we go based on this last one here, okay, we also know that this has 2 humps, so we're going to only have 1 hump on the second, on the derivative, okay? Let's look at the other one. So it says whenever we have a point of inflection, that means we either have a max or min. So if we take a look here, here's our point of inflection around here. So that means we're either going to have a max or min. Now to check, we know that we're concave down to the left of that point of inflection, and we're concave up to the right of it. So that means we're concave down, which means we're negative, and we're concave up after that, so we're positive. So that means we have a minimum because we're going down to up. So what I'm going to do is I'm going to go ahead and just estimate where my minimum is going to be, and I can put it anywhere as long as it's beneath here, okay? So if you kind of now pay attention to this, we're going to be above the x-axis anywhere from here to here because we're increasing, okay? So from here, anywhere in less than -3, I'm going to be above the x-axis. So here I'm above the x-axis. And if you notice, look, here, my slope is very positive, okay? As opposed to this portion here. So here, if you look at the tangent line, the slope of that line is pretty steep. But as I get closer and closer to the maximum, look, it's starting getting closer and closer to 0. So here I'm getting closer and closer to 0, okay? All right, after that, we're decreasing, so I'm going to be underneath the x-axis. Okay, and I'm going to bend it a little bit because it's a polynomial. This was going to be a polynomial here too. And I'm still underneath the x-axis, and I'm getting closer and closer to this x value. But the reason I'm getting closer to the x-axis, I know to bounce up, is because look, the slope here is pretty negative compared to this slope here, this tangent line. And as I'm getting closer and closer, look, it's getting closer and closer to 0. It was really negative, now it's getting closer and closer to 0. So here is really negative and getting closer and closer to 0. After this, I'm going to be increasing, and it's going to be it's going to be a little steep, and then it's going to get really steep. So that means I'm going to shoot up just like that. So if you take a look at this, look, if this graph were something like x cubed plus something, then the derivative of that would be 3x squared. Okay, now this is just an example. I'm not saying that's the graph of that. But look at this. This is squared. This is cubed. The squared has only one hump. Okay.